All right, settle in, grab those notebooks, and welcome to today's masterclass. I'm your teacher, and I am absolutely thrilled to help you prep for your OCR AS level computer science exam. Today, we are tackling a massive, absolutely crucial chunk of the syllabus, specification 1.1.3. This is literally the bedrock of how a computer actually functions, and nailing this section is going to secure you some serious marks on test day. So I need your full focus, high energy, and readiness to learn. Let's get into it. Here is our game plan for today's session. We'll start with memory, specifically RAM and ROM. Then, input and output devices. After that, we'll hit storage types, followed by virtual storage. And finally, we'll wrap up with a rapid-fire pop quiz. Section 1. Memory, RAM, and ROM. Okay, let's dive right into this head-to-head comparison. This is a fundamental concept that examiners just love to test. On one side, we have RAM, or random access memory. Think of RAM as your physical desk. It holds everything you are currently working on right this second. You know, your running programs, the operating system, your open files. But it's volatile. That means the absolute second the power goes out, poof, the desk is wiped completely clean. On the other side, we have ROM, or read-only memory. Now, this is non-volatile. Even without power, it remembers. ROM holds the essential, unchangeable instructions needed just to boot the machine up and get the hardware talking to each other. Now, pay attention to this because it's a direct tip straight from your textbook. The examiners aren't just looking for you to say volatile versus non-volatile. That's honestly not enough. You must explicitly state what they store. RAM stores the current operating system, user applications, and open documents. ROM stores the startup software and hardware initialization instructions. You need to commit that exact distinction to memory. To put a really fine point on it, here is your crystal clear exam-ready definition of RAM. It's essentially the high-speed scratch pad for the CPU. Because its access times are drastically faster than a secondary storage hard drive, the CPU demands that programs be loaded into RAM before they can actually be executed. Just don't forget to hit save, because once that power drops, everything in RAM is gone for good. Section 2. Input and output devices. Time for another critical exam cheat code. The test isn't just a basic vocabulary quiz where you point out a mouse or a monitor. No way. The examiners are going to give you specific, real-world computing scenarios. You'll need to decide the most suitable device and justify exactly why it's the right tool for the job based on how it actually works. Application is absolutely key here. So, the crucial point is understanding the underlying mechanics of a device so you can apply it to a scenario. Take barcode scanners, a really classic input device. They read those familiar black and white lines you see on basically every product. But how? Well, different line thicknesses represent different values, which then correspond to a unique product key in a database. But here is the absolute genius part. They have specific markers at the start and end called terminators. These terminators tell the scanner the orientation of the barcode. That means a cashier can scan your groceries upside down, sideways, or backwards, and the input still works perfectly. Section 3. Magnetic, flash, and optical storage. Let's start with the reliable workhorse of standard desktop computing, magnetic storage, which you probably know better as the traditional hard disk drive, or HDD. These devices offer incredible high-capacity storage. They give you the absolute best compromise between massive storage size, decent performance, and really low cost. They work using a physical spinning magnetic platter and a mechanical arm with a little read head that swings across to read and write data. But remember, because they have actual moving parts, they are significantly slower than RAM or our solid-state options. And that brings us perfectly to our next category, flash storage. Think USB memory sticks, SD cards, and solid-state drives, or SSDs. Flash uses solid-state technology, specifically something called EEPROM. That stands for Electronically Erasable Programmable Read-Only Memory. Notice what's missing here? There are no spinning disks, zero moving parts. This total lack of physical motion means data access is incredibly fast. They're also a whole lot lighter and much less susceptible to physical shock if you drop them, making them the absolute perfect storage solution for laptops, tablets, and smartphones. Our third category is optical storage. These are your CDs, DVDs, and Blu-rays. These devices work by using highly focused lasers to burn microscopic indentations into a spiral pattern right on the disc. These indentations, along with the flat areas between them, are known as pits and lands. When the drive is reading the data, a laser is bounced off the surface, and the tiny change in light interference between a pit and a land is translated back into the ones and zeros of binary data. Pretty cool, right?
Section 4, Enterprise and Virtual Storage.
Now let's shift gears and see how this all scales up to build a massive network. You see, a simple hard drive just won't cut it for a giant corporation. They use something called a SAN, or a Storage Area Network. A SAN acts as a powerful gateway linking together multiple specialized drive configurations, like RAID arrays, all across a network. Even though there might be dozens or hundreds of different physical disks, the SAN treats them all as block-level devices, efficiently serving files to the entire enterprise. But managing all those disparate RAID arrays and SANs, that is incredibly complex. And that's exactly where virtual storage comes in. Virtual storage provides an abstraction layer. It basically hides all the messy, complicated hardware differences underneath. By using a virtual controller, network administrators can bring all these completely different storage devices together and administer them centrally, almost as if they were just one massive single logical drive. It translates generic requests, like a simple backup command, into the highly specific hardware instructions needed for each unique physical device. Section 5, time for the final exam pop quiz. Let's see what you've retained. Question 1. Think back to our memory comparison earlier. Which type of memory specifically stores the boot-up software required to initialize the hardware? Lock in your answer. Got it? The answer is ROM, or read-only memory. It's non-volatile and keeps that vital startup data safe even when the machine is completely powered off. Let's keep the pace up. Question 2. In a barcode scanner, what specific feature allows the reader to know the code's orientation so the cashier can scan it upside down? Think about those specific markers. If you said the terminators at the start and end of the barcode, you are spot on. Moving on to question 3. We talked about 3 main storage types. Which type of storage device retains its state without power, uses EEPROM technology, and entirely lacks physical motion? Any guesses? That perfectly describes flash storage, or solid-state storage. No moving parts means much faster access times. Question 4. Let's test your specific terminology. In optical media like a CD or DVD, what do we actually call the microscopic indentations and the flat spaces between them that are used to store binary data? You need to know the exact phrasing for this one. They are called pits and lands. And the final question, question 5. What technology acts as an abstraction layer for different SANs and RAID arrays, allowing them to be administered centrally as a single logical drive without worrying about individual device differences? Think big enterprise networks. That is the exact definition of virtual storage. Excellent job. If you nailed those, you are well on your way to mastering OCR Spec 1.13. We have covered a huge amount of ground today in this explainer, from the fundamental volatility of RAM all the way to the massive abstraction layers of enterprise virtual storage. But before we wrap up today's session, I want to leave you with a bit of a provocative thought to ponder. As virtual storage becomes vastly more powerful and cloud computing completely takes over the enterprise space, do you think local physical storage drives on our personal machines will eventually become completely obsolete, just entirely replaced by virtualized networks? It's something to think about. Keep studying hard, review your definitions, and I'll see you in the next session.